All right, gang, math 6610 again. Wanted to stop the last video because there are a couple of things that were bugging me. I liked some of the things that I presented, but there was a couple of things that were driving me insane. So let me explain what's going on. First of all, the drawing, I wanted it a little clearer and a little neater about what represents what area represents the power. In this case, 1 minus beta. That's uh, the orange, and this area right here represents the probability of a type 2 error for the reasons I explained in the previous video. So the way that I kind of framed out type 1, type 2 errors, effect size, power, everything was fine. So I didn't want to scrap the video, but you may have noticed that when I tested when I calculated the power, got ready to calculate the power and the probability of a type 2 error, we used this contingent on the mean being 105. Well, it kind of gave a goofy drawing because 105 is less than a 105.88, and so I pumped the brakes and didn't like that. So here we are. So we're going to adjust things a little bit. And don't get me wrong, you can do that. This line in the sand, if you will, can be over here. It just makes a cleaner drawing when introducing the idea and the concept of power and probability of a type 2 error. So really what we need to be able to find is we need to be able to find this area right here, right? And it's just very, very easy to do. So we would use the P norm. I need the area above 105. Now, should be red flag, right? P norm by definition in R gives me area below. So I know that I must subtract that from 1. We're drawing by definition from this distribution, so I have to have a mean of 108. And since this is a sampling distribution, we no longer rely on the population standard deviation, we rely on the standard error. So this area, oh, well, if I could spell, it would really be magnificent. This area gives us the power. So we know that 1 minus beta is equal to 0.76. And so therefore I know that beta must be equal to 0.24. So if the population mean is 108, we land with a beta, with a power very close to the 0.80, which is the desired level of our power. Now another way, notice that of 1 minus beta, just with simple arithmetic, we can find that beta is 0.24, but we could also find that by finding just the area below, which would, of course, just be this part. So 0.24 would be the probability of a type 2 error. So useful in day-to-day research, education research? No, it isn't, because first of all, we never know if this is a correct statement or not. We're testing it. We're using a single sample from infinitely many to make a decision. And if we do know this is false, we never know what the true value of the mean is. But nevertheless, it's just kind of a classic textbook demonstration of where the power lies and where the type 2 error. Now, what happens as this 108 increases, right? So again, we're working under a type 2 error. A type 2 error is the claim is false. Well, if it's false, it's got to be something different. What is it? So we're living in that world, if you will. So if this 108 increases up to 110, what happens with these errors? I'm sorry, what happens with these two regions? Specifically, what happens with that error? What happens with our power? Well, if this distribution shifts to the right, it should be very easy to see that this area gets bigger and this area gets smaller. So when the true distance between the hypothesized value and the true value increases, we increase our power, we have more potential, higher probability of rejecting a false null, and then this value actually gets smaller. So the probability of a type 2 actually gets smaller. That's about all I have on that, but I do want to circle back. So what does effect size do? Well, effect size, and again, effect size is very complicated because effect sizes vary per statistical technique. So I'm not going to get into calculating effect sizes until we get in. The game plan will be I'll do a one sample z-test, then we'll move into a one sample t-test, then we'll get into two sample tests, get into ANOVA, ANCOVA, repeated measures, all kinds of cool stuff. But in general, what the effect size does is it takes takes sample size and p-values and all of that out and just gives a standardized measure of this difference. And I think it's important to know at this point that when conducting inference, we want to report a test statistic. We want to report, we're forced to report things like degrees of freedom and confidence intervals and p-values. But I don't think a test is complete unless we also report the effect size. So that's all I got. Take care.